36, extreme weather. Today's purpose is to read data and other information from tables and graphs on the topic of global warming, and more particularly, does it cause more extreme weather? Relevance. This will help me to understand the debates on the topic. Success. You'll be able to state your thoughts on the issue and back it up with facts. Today's grades, we have one homework assignment. It's reading a bunch of tables and graphs. It's on Schoology. Test 3 is coming up in a couple days on Friday. Classwork review number 1. The UN says that global warming started in. Their graphs show 1976 as the first detectable uptick in the temperatures after a long time of slow, steady decreasing in temperatures. On the quiz or a test or something like that, I might just simply say the 1970s at some point. Not specifically 76. Greenhouse gases, the main one that we're talking about is CO2, but there are others such as methane and water vapor. Water vapor and methane are stronger greenhouse gases than CO2, but we are more concerned about the CO2 because that's the one that we are really changing a lot. Water vapor is not as powerful molecule per molecule as far as I understand, but there's a lot of it. Maybe 4 to 6% of the atmosphere is water vapor, less than 1% is carbon dioxide. Methane, molecule for molecule, is about 30 times more strong at capturing infrared radiation, capturing heat, so to speak, than CO2. And there is some concern about the methane. There are concerns about people-caused methane releases as well, but it's not used in as many different things as CO2, so again, it doesn't get the attention. When people talk about the impact of cows on the environment, they're mostly talking about the methane that they burp and fart. CO2 does come into play when it comes to cattle farming with all the trucks that are used to haul them around and the tractors that are used to grow their food and all of that. But most of the conversation about cows deals with methane. And there are other few situations where methane is discussed in terms of global warming as well. By itself, CO2 will only raise the temperature by about 1 degree. That in itself is not bad. The problem is that there are other things that might amplify that, and those things are called positive feedbacks. One example of a positive feedback would be water vapor. The warmer it gets, the more humid it can get. The more water vapor there is, the warmer it's going to get because it captures more of the heat. So it gets even more warm, so it captures even more water vapor, which makes it even more warm, which captures more water vapor, etc., etc., etc. It gets worse and worse. But there's also things called negative feedbacks that fight back this 1 degree of warming. An example that could be, again, water vapor, paradoxically. With more temperatures, there's more water vapor, which could possibly lead to more clouds. More clouds could possibly shade the Earth, making it cooler and fighting back this 1 degree of warming. So, which is it on the whole? Both of them are going to happen to some degree, but which one is stronger, the positive feedback of water vapor or the negative feedback of water vapor? That's the point of the debate. Most people think that if the world warms by 2 degrees, things will be okay. So 1 degree is going to be from the CO2. They're willing to say 1 more degree with positive feedbacks of one sort or the other. We can still survive those. That won't cause great distress. We can adapt to that pretty well. And so whenever they have these treaties and agreements, one sort or the other, that seems to be the goal. The nice thing that I just read recently is that over the past couple decades, we are on track to raise the temperature of the world 1.3 degrees over the next century if things continue as they are right now. So, according to our observed temperature rise, we are okay. The problem is, some people think that the positive feedbacks will kick in more strongly later on, and things might go above the 2 degrees. That's a point of debate. Number 7, surveys that ask specific questions of scientists show that 52% of them think that both global warming is real and mostly caused by the people. You often hear about 97% consensus. That is different kinds of data. One time that they came up with 97 was a very small survey, only 77 people. That is not large enough to make a generalization of all the scientists in the world. I took a stats class in college, and one of the things I took out of that is when you have a giant population like the entire country with millions of people, you can actually get a very good judgment as to what everybody thinks by only polling about 2,000 to 3,000 people. Believe it or not, that's enough, and statistically it works out. Well, this 77 doesn't quite reach up to that point percentage-wise for all the scientists of the world, so some people discount the survey in that regards. This 97% also comes from surveys of printed articles. But you have to remember that the printed articles, they have problems too. Various types of attacks have been made on that study. One of them is that the journals are only allowing certain papers to be published, and the editors are the ones who decide which ones get in, and the editors have their own biases. So that could skew things. And there are other things as well that people have commented upon about the survey of printed articles. Okay, over the last 130 years, sea levels have been rising. This is before global warming has started. Global warming, remember, started in the 70s. Sea levels have been rising for 130 years. And as the world has gotten warmer and warmer over the last 50 years, the sea levels have not increased in their rate of going up. Glaciers are oftentimes pointed at to say, look, that's global warming, but actually they started to melt in the 1800s. Again, a lot before human-caused global warming. And the data that I have seen indicates that the rate of disappearing, the rate of melting, has not increased since the 70s. Number 11. Arctic ice. That's the North Pole. That has shrunk more quickly than the computer models have predicted. So in this situation, global warming is worse than they had thought it was going to be. However, the Antarctic ice at the South Pole has increased, whereas the computer models, they predicted that it would go down. So the computer models have some problems to them. When they look at the computer models making predictions about temperatures, they had usually out of 102 different computer models making different predictions, the average of those was 3 times too hot, 3 times hotter than actual observations turned out to be. A 300% error. Because of that and other things, the biggest scientific journal in the world, that's called Science. That's the name of the journal or the name of the magazine. It says the computer models are not good for making predictions. So what are they good for? They're good for looking at relationships. If we increase CO2, what will happen to the temperature? Will it go up or down? That's seeing a relationship. That's not making a prediction as much as they are claiming. They're not saying with this computer model at the year 2052 the temperature is going to be up 3.2 degrees. That's more of a prediction, stating a specific year, saying a specific degree rise. The journal Science says that these models are not good for that. but just simply seeing, is it going to be a positive feedback or a negative feedback with the water vapor? That they could probably figure out with these models. Okay, videos. Let's watch this video. Climate change, what's so alarming? Okay, remember that I was saying earlier in this unit that it's not just a matter of there being two sides to the story, skeptics and alarmists. There are people in the middle to various degrees, and this is a well-known middle person. He agrees that yes, indeed, the world is warming, and yes, indeed, it's probably significantly due to humans. I don't know if he thinks more than half or less than half, but still very significant human input. But the reason that we put him in the middle is because he doesn't think that the best way to spend our money is to combat CO2, but rather to adapt to the new situation and to spend our money on other things that kill more people, like malaria and the economies and poverty and that kind of a thing. So anyway, this is a lukewarmer, sometimes we call that group of people.
Carbon emissions are rising, and faster than most scientists predicted. But many climate change alarmists seem to claim that all climate change is worse than expected. This ignores that much of the data is actually more encouraging than expected. Yes, Arctic sea ice is melting faster than models expected, but models also predicted that Antarctic sea ice would decrease, yet Antarctic sea ice is increasing. Yes, sea levels are rising, but the rise is not accelerating. If anything, two recent papers, one by Chinese scientists published in January 2014 and the other by U.S. scientists published in May 2013, have shown a small decline in the rate of sea level increase.
Okay, we've done now questions 1 and 2. Go ahead and try to answer those if you haven't already. Look at questions 3 and 4 so you can anticipate what to listen for.
We're often being told that we're seeing more and more droughts, but a study published in March 2014 in the journal Nature actually shows a decrease in the world's surface that has been afflicted by droughts since 1982. Facts like these are important because a one-sided focus on worst-case stories is a poor foundation for sound policies. Hurricanes are likewise used as an example of things getting worse. But look at the U.S., where we have the best statistics. If we adjust for population and wealth, hurricane damage during the period of 1900 to 2013 actually decreased slightly. At the UN Climate Conference in Lima, Peru, in December 2014, attendees were told that their countries should cut carbon emissions to avoid future damage from storms like Typhoon Hagupit, which hit the Philippines during the conference, killing at least 21 people and forcing more than 1 million into shelters. Yet the trend for strong typhoons around the Philippines have actually declined since 1950, according to a study published in 2012 by the Journal of Climate. Again, we're told that all things are getting worse, but the facts don't support this.
Okay. We're done 1 through 4 now. Please look at 5 and 6 to anticipate what's to listen for.
This does not mean global warming is not real or a problem, but the one-sided story of alarmism makes us lose focus. If we want to help the world's poor, who are the most threatened by natural disasters, it's less about cutting carbon emissions than it is about pulling them out of poverty. The best way to see this is to look at the world's deaths from natural disasters over time. In the Oxford University database for death rates from floods, extreme temperatures, droughts, and storms, the average in the first part of last century was more than 130 dead every year per million people. Since then, the death rates have dropped 97% to a new low in the 2010s of less than 4 per million. The dramatic decline is mostly due to economic developments that help nations withstand catastrophes. If you're rich like Florida, a major hurricane might cause plenty of damage to expensive buildings, but it kills few people and causes only a temporary dent in economic output. If a similar hurricane hits a poorer country like the Philippines or Guatemala, it kills many more people and can devastate the economy. So let's be clear, climate change is not worse than we thought. That doesn't mean it's not a reality or not a problem. It is. But the narrative that the world's climate is changing from bad to worse is unhelpful alarmism that prevents us from focusing on smart solutions. A well-meaning environmentalist might argue that because climate change is a reality, why not ramp up the rhetoric and focus on the bad news to make sure the public understands its importance? But that's exactly what we've done for the past 20 years. Yet, despite dramatic headlines, apocalyptic documentaries, and annual climate summits, carbon emissions continue to rise, especially in rapidly developing countries like India, China, and many African nations. Alarmism has encouraged the pursuit of a one-sided climate policy of trying to cut carbon emissions by subsidizing wind farms and solar panels. Yet today, according to the International Energy Agency, only about 0.4% of global energy consumption comes from solar photovoltaics and windmills. And even with exceptionally optimistic assumptions about future deployment of wind and solar, the International Energy Agency expects that these energy forms will provide a minuscule 2.2% of the world's energy by 2040. In other words, for at least the next 2 decades, solar and wind energy are simply expensive, feel-good measures that will have an imperceptible climate impact. Instead, we should focus on investing in research and development of green energy to lower its costs. So everyone will want it, including China and India. We urgently need a more balanced climate conversation if we ought to make sensible choices and pick the right climate policy that can actually help fix climate change. I'm Bjorn Lomborg, President of the Copenhagen Consensus Center.
Next page. Okay, this graph shows us ice on Greenland. It says here gigatons of ice. This is the the estimates of the ice that is present. And from the years 1880 up to 2020 or 2020. And there is an inset here as well. So this graph was made in response to this small inset being published. And this inset was published with an article saying, wow, look how fast the ice sheet is disappearing. Look how steep that line is. Number 9. There are 2 graphs here that show the melting of ice on Greenland. Both show true data, which makes the melting look worse. Okay, well, obviously, I think this one makes it look worse because it's going down so much faster. It goes up and down, up and down, up and down because of the summer and winter, that oscillation. But gradually, it's going down at a consistent clip here. But why does this, mathematically or organizationally, why does this look so much worse than that? This one doesn't show movement because it shows the entire scale from 0 all the way up to the current 2 gigatons. This only shows a small section zoomed in. This inset does not have the 0 mark. The small inset graph makes things look worse because it doesn't show the 0 mark. Relative to what is this going down? That's the point. What years does a small inset graph cover? I believe that says 2002 to 2014. What years does a big graph cover? Okay, now, careful, don't say 1880. The first data point is 1900. And the last data point is like 2015. Those are estimates there. I might be off by a little bit. Let's see, what did I say here? 2016? And this was C, and this was B. Okay. How many more years does the big graph cover? Well, let's see here. 2 to 16. We include the year 2002 plus another 14 years, so that's a total of 15 years for the little inset. Here we have the year 1900 plus another 115, so that's a total of 116. Can we tell from the tiny insert graph if the downturn of ice started with human-caused global warming in the 1970s or if it started earlier from natural causes? Okay, it started off going down. We don't have any flat area and then going down. And so we can't tell when this started. Can we tell when the downturn started? No, we cannot. Okay, now, how many tons is shown here as melting during these 15, 16 years? Goes from 0 down to 1,000. Can you see in there, does it say gigatons or anything like that, or is it just plain old tons? Let's zoom in. Greenland. Change in mass. I can't quite make that out if it's saying anything about the units. How about you guys? Can you make that out at all? I've maxed out my magnification. Okay, but the point is that at this rate of decrease, it's still not perceptible when we look at the entire gigatons of ice on Greenland. I believe there's an article here later on that describes how many thousands of years it is before Greenland would be completely melted free at the current rate. Alrighty, we move on. For your homework 136 on Schoology, you're going to be looking at all these different stations, I call them. You look at a graph and answer the questions. Look at the graph, answer the questions. Report your answers to Schoology.